Hey, what's up everybody? It's Math at Home here. Today is our third video, third lesson, which we're going to analyze the questions on page 165. So grab your books, copybooks, and your stationery. Open your books on page 165, practice part, and let's get it started. Okay, as we have on page 165, the first question talks about different kinds of triangles. Here are 5 different triangles. Okay, we have different triangles as triangle A, B, C, D, and E. A says, name each triangle. In order to be a review, I'll tell you that. Okay, so we had 3 kinds of triangles. We had an isosceles triangle, which had 2 same sides. We had an equilateral triangle, which had 3 same sides. And we had a scalene triangle, which didn't have any same sides. Alright then, so putting these definitions into consideration, we start by A. As I could see, I have 2 equal sides here. A is going to be an isosceles triangle because we had 2 equal sides here. About B, as you could see, none of the sides are equal. So actually the triangle is a scalene triangle. About C, as you could see, all the sides in triangle C are equal size. Therefore, we're going to have an equilateral triangle. About triangle B, these 2 sides are equal. Then we're going to have an isosceles triangle again. And about E, regarding the sides, none of them are same. But if you look at the inner angle, one of them is a right angle here. Therefore, we're going to have a scalene triangle because of the unequal size. So we're going to have scalene triangle. But it is a very specific condition here, which is a right-angled scalene triangle. So it's a right-angled scalene. Question B says, which triangle have reflective and rotational symmetry? Okay, in order to remind you the reflective and the rotational symmetry, the reflective symmetry talks about if we have a reflection line which can divide the shape into 2 similar parts. For example, let's say about this rectangle, if we have a line from here, actually this is going to divide my shape into 2 equal parts. So if I fold it from this line, this part is going to cover the other part. Or else I can have a line of symmetry horizontally from middle. So this part this time is going to cover the other part. So I would say that rectangle, my rectangle here, has reflective symmetry. For example, in the semisphere here that I have, if I draw a line like this, I'm going to have a reflective symmetry because the reflection of this part is exactly equal to the other part. But what about the rotational symmetry? I told you that if we have a shape, let's say something like this, the rotational symmetry talks about if any rotated figure of the shape is going to match its original one. For example, if I want to fully rotate this shape, it's not the same as you could see. Mine was horizontal, now it's vertical. Yes, I went half a turn and I got a shape which is the same as the previous one. So we have the rotational symmetry. Let's continue. We might have more. No, no, still no. I'm about to make a full turn and over. We do not count the full turn itself. So before the full turn, halfway through the rotation, I faced a shape which was identical to this one. So in this case, I would say that I have rotational symmetry about my rectangle. Now let's think about the shapes. Question B says, which of the shapes have reflective and rotational? Okay, so as you would see here, about triangle A, I have the reflective symmetry because I can divide it into two equal halves. But about rotational symmetry, I cannot get the same shape because originally it's pointing downwards. If I rotate it, it's either going to point rightwards, leftwards, or upwards, which is going to be different from the original shape. Therefore, I'm not going to have any rotational symmetry. About B, we have neither of them. About C, I could have a reflective symmetry, and if I start rotating this shape, we are going to see the same shape 3 times because it's perfectly symmetrical. Therefore, C could be the answer. About D, however, we cannot because we have reflective symmetry, but we do not have rotational symmetry. About E, the situation is the worst, just like B. So the only possible answer for B is going to be triangle C. Which triangle have only reflective symmetry? So as I told you before, the answers are going to be A and D, which have reflective symmetry but not rotational. Which triangle do not have either reflective or rotational symmetry? So the scaling triangles obviously are the answer for this question. Part B, 3D and 2D shapes. How many lines of symmetry does this pattern have? Listen, if I want to draw my line of symmetry horizontally, once I fold this part over the other one, this square is going to appear here. So it's not going to be the same because we didn't have a square here. So I cannot accept this one. It's impossible. Let's try the vertical line. If I try folding it from here, and let's say this part is going to go to the other side, this square is going to appear here. While originally I don't have any squares here, so it didn't work either. Let's try the diagonal lines. All right. Now, let's see if I want to fold it. Everything is going to be identical on both sides. So this square is going to go there. This trapezoid is going to go there. The half of the triangle is going to travel here. Again, this one is going to travel here. Everything is going to be symmetric. So we have one line of symmetry as this diagonal line, and the other one here, the other diagonal line. So in total, we have 2 diagonal lines. which are these and this one. Part B. How many pairs of parallel lines can you find that make up the sides of the colored shapes? We're talking about parallel lines, all right? Let me choose another color for this one. Okay, I'll erase these diagonal lines and the answer for this one also. Okay, so we're talking about parallel lines. Let's get it started. About parallel lines, we could say these, wait, it's not obvious. Yeah, blue is better. We would say these two are parallel. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 pairs of parallel lines. About part C, how many pairs of perpendicular lines can you find that make up the side of the colored shapes? All right, let me clean these ones. Let's go for the perpendicular ones. So, as a reminder, I would tell that a perpendicular angle is a right angle. So we're going to look for any right angle. Okay. So this side and this side, they are making a right angle. 1, this one and this one, 2, 3, 4, 5, 6, 7, 8. This one and this one, 9, 10, 11, and 12. So we have 12 pairs. Estimate, measure, and name the angles of one of the trapezia. Fine. I need to clear out these. Okay. Okay. So apparently, I'm not going to be able to show how to use the protractor on either of the trapezia because I cannot do it right now. But in order to illustrate it, I'll try my best actually. Let's choose a vibrant color. This could be good. Okay, so imagine if my protractor is something like this with the center. All right, so you are going to put the center in the corner of the vertex, as I told you before. So the center is going to be here, and this line is going to be aligned with this line. So, okay. So it's going to look something like this, right? Okay, so once you measure this one in your book, practically, I mean, in real life, you will notice that this angle is going to be 45 degrees. And this angle, however, and this angle following that, see, we told that this is a symmetric line. So what it means, whatever that's happening here is going to be identical on the other side. So obviously this is going to be 45 degrees. And if you measure this angle, you will end up with 135 degrees. So 135 degrees for this one. In other words, if we want to name these angles, 45 degrees is going to be an acute angle, and 135 is going to be an obtuse angle. Fine. Sketch the nets for a triangular prism and a cuboid. Okay. Let's try it. A triangular prism. So before I want to go for it, I'll give you some time to think about the nets of these two 3D shapes, please. So the shapes were triangular prism and cuboid. Please take your time and think about the nets. Okay, let's draw it together. As the net for cuboid, we all know that a cuboid has 6 faces. So 4 of them are going to be built up by rectangles and 2 are going to be squares. So we're going to have 1, 2, and 3, and 4 rectangles. Therefore, we're going to have this one and this one. So this is the net of a cuboid. About a triangular prism, we're going to have 1, 2, and 3. We're going to have 3 rectangles. Excuse my bad drawing, by the way. And 2 triangles. So they're going to fold upwards, and these are going to fold upwards as well to make the triangular prism. Part C. Write the coordinates of the letters A, C, and D on the map of the nature trail on page 164. Okay, so I hopefully included this in advance. Yes. So about the coordinates of points A, B, C, and D, we are going to have. So A is going to be, here, it is here. Therefore, we're going to have, let me point them out so that you could see. Okay, so A is here, B is here, C is here, and D is there. So for A, I will have x2, y2. For B, I'm going to have x4 and y7. C, on the other hand, has 9 as x and 9 as y. And D has 11 as x and 4 as y. These are the coordinates for 4 points. Question 2. Orlando takes another photograph at location 5, x5, y9 on the map. He then crosses the nearest bridge. What are the coordinates of the nearest bridge? Okay, let's get back. The coordinates were x5, y9. If we want to show it, it's going to be x5 and y9. If the person is going to take a photograph here, then the nearest bridge for him is going to be this bridge, obviously, right? Because it's closer to this bridge than it is to the other one. Therefore, we're going to write the coordinates of this one. So we're going to have x6 about bridge. We are going to have x as 6 and y 12. This is the coordinates of the bridge. D. Transformation. What are the coordinates of these shapes after the reflection in the mirror line? Fine, pretty much easy. This is our mirror line. Let's reflect them. So I'm starting from here. So let's say 1 and then 1. So this corner is 1, 2, 3, 4 away from this one. So let's do the same thing. 1, 2, 3, 4. This is another way of finding the corner, so I found it already. So this one is left, so we will say 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So we're gonna end up here. So our triangle is going to be like this. Okay, let me color it to make it obvious. So this is the reflection of our triangle. About square, however, let's start from this corner. 1, 2, 3, 1, 2, 3. So we will end up here. The other one is 3 blocks away, so let's go 3 blocks away. Okay, then we are here. Okay, then this is the side. So the other one is 3 away from this one. Yes. So about the other one, we say 1, 2, 3, 4, 5, 6. Let's continue. 1, 2, 3, 4, 5, 6. Okay. So the reason actually I went over it, as you could see here, is that I didn't want to mix them up. Therefore, I'm going to have this side as here. So as you could guess, our square is going to form like this. This is our square. Question 2. Translate the original square, 1 square left and 2 square down. So it says 1 left, 2 down. I'll use another color. 1 left and 2 down. Okay. Let's pick this corner, for example. I go 1 left, 2 down. It's here. So I don't need to actually have these ones. Let's go for this one. 1 left, 2 down. So I don't need these ones. Let's go for this corner. 1 left, 2 down. And 1 left, 2 down. So this is going to be our square. We don't need these actually. So the blue square is the translated form of the original square by 1 left and 2 down. So this basically was our lesson for today's video about answering the questions on page 167. Hope to see you well next session. Bye bye.